Great. So, hello everyone. Today we have a very special session, an online session with the Colombian combinatorics in our SPAAM seminar. And we're going to be introducing Sergio Alejandro Fernandez de Soto Guerrero as our first speaker. He'll be talking about MathMagic, a positroidal action over a deck of cards. Okay, please take it away, Sergio.
So thank you so much, Luisa, for the presentation. Okay, I was scared for a moment because I saw me like freeze. Again, so thank you so much for the presentation and for the invitation to speak here. So probably will be a little bit different that you are used to, because as you hear in the title, we are going to talk about math and magic. So for that, I will do two experiments. So I don't know if someone here can open the mic. Yes, no, or in that case, I'll also ask for your help, Luisa or Jerónimo.
I can do it.
Okay, perfect. So let me change camera to this one. So perfect. So now the idea is for you, Jerónimo, and also for all the ones that are seeing us, I have the ace, the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 10. So I have the cards in order from ace to 10. But what happens if I start to dealing cards? For example, I start to dealing the ace, then the 2. But what happens if I switch these two cards? Then it doesn't come 3 and 4. It comes 4 and 3. Then we have the 5. But if we do a switch here, then it doesn't come the 6 and 7. It comes 7 and 6. What I'm doing, I'm messing the order. Okay? So, Jerónimo, a question for you. Do you intuit that you have a really good intuition?
Yes.
Okay, perfect. That's the attitude. And what happened with the camera? Okay. We are back again? Yes.
I think we have to mute ourselves.
Do anyone saw the camera?
No, I think I cannot see it.
We can wait, don't worry. The magic doesn't happen for the moment. Okay, perfect. So, Jerónimo, can you see the camera?
Yes.
Okay, perfect. So, what happened when I do one of these switch? I'm messing the order. So I will do one of these switch, but not in camera. So you cannot see where I'm doing the switch, but your intuition does.
Okay.
So what I will do is I will start to dealing cards one by one, and when you feel it, Jerónimo, you can say me switch, and then I will take the two cards, I will switch it, and maybe you can say me switch in the same spot that I did. Who knows? Okay, I know that there is a little delay, so I will do it like slowly, and when you feel it, you say me switch.
Switch.
Switch here. Are you sure?
Yes.
Okay, I will switch the cards and then put it on the table, and the rest on top. Well, Jerónimo, it doesn't matter if I try to mess the order, because your intuition leads us to have the ace, the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 10. But wait, because we only did once. So what happened, for example, if now I will do again, not on camera, I will do two switches. Again, you cannot see when I'm doing it, but your intuition does. So again, Jerónimo, I will start to dealing cards, and when you feel it, you can say me switch, and then I will shift the cards, and maybe you can say me switch in the same spot that I did. Okay?
Okay.
Listo.
Switch.
Switch. Okay, I will do a switch.
And switch.
Switch. Okay, I will do the second switch. Well, Jerónimo, again, it doesn't matter if I try to mess the order, because your intuition leads us to have the ace, the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 10. But wait, Because the first time I said once, the second time we did 2. So now, for this, I will not say how many switch I will do, because now your intuition will tell you how many and where. Let me see a key. Okay, perfect. Okay, perfect. So again, Geronimo, when you feel it, you can say me switch how many times as you want, wherever you want. And maybe you can say me switch in the same spot that I did. Okay?
Okay, switch.
Switch. Okay. Do you want another switch?
Yes.
Okay. Do you want another one?
No.
No? Another one?
No.
Another one?
Yes.
Yes. Okay. And the last switch. So, Geronimo, as I told you, it doesn't matter if I try to mess the order, because your intuition always leads us to have the ace, the 2, the 3, the 4, the 5, the 6, and all the cards in order. This is good that you intuit, that you have a really good intuition. Now I know that in this moment probably you are like choking or clapping. But okay, this is the first experiment. So for the second experiment, can you also help me, Geronimo?
Of course.
Okay, perfect. Now, for this one, I have something here. So this one here is a prediction. Do you know what a prediction is?
Yes.
Okay. A prediction is something that I wrote, that it will happen in a future moment. But now we are in the present, so I will put it here. Okay? It's on camera. Yeah, you can see it on camera. So for this, I will use some few cards, because I want to do some chaos, but I don't want to do like normal chaos, because if you see magician always shuffle cards like face down, I want to do it more like chaotic. For that, I will shuffle cards face up and face down. Of course, this one allows me to have different ways to shuffle cards. Well, new ways to shuffle cards. For example, I can deal or turn over, deal, turn over, deal, turn over, deal, turn over, deal, or turn over. So for example, Geronimo, do you want to deal or turn over?
Deal.
Deal. Do you want to deal or turn over?
Turn over.
Do you want to deal or turn over?
Turn over.
Turn over. Okay, perfect. Here, do you want to deal or turn over?
Deal.
Deal. Do you want to deal or turn over?
Deal again.
But which one? These ones here or these ones here?
The ones in the right.
In the right. So these ones.
Oh, no, the other ones.
These ones.
Yes.
Deal.
Yes.
Okay. And these ones?
Turn over.
Turn over. Okay. Do you want to do it one more time, or once more, or this is enough?
No. That's enough. That's good.
Okay, perfect. So now, Geronimo, this is the more important question I will ask you. Imagine that this is like a book, and you can close a book in 2 different ways. You can close it from left to right, or from right to left. How do you want to close it?
From right to left.
Right to left, so like this.
Yes.
Okay, perfect. So I will do it, and that's it. Do you remember that I told you that I have a prediction that something that will happen in the future?
Yes.
Well, the future is now. Because here, I hope that you can read it. I tried my best. You can say it? I will say it out loud. So it says, at the end there will be 5 face-up cards and 5 face-down. What does that mean? That after you told me if deal, turn over, after I told you if you want to do it one more time, you say me no. We end up here having exactly 1, 2, 3, 4, and 5 face-up cards, and 1, 2, 3, 4, 5 face-down cards. But wait, because this is impressive, but I have something else, because this is not the only prediction that I have here, because I also have furthermore. It says, the red ones will be separated from the black ones. What does that mean? If you see, if all these cards are reds, these one here are, or would be, black, 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 and black cards. Now, probably in this moment, you are freaking out, like saying, no, how is this possible? Oh, no, magic. Well, this is not a spoiler. Let me change again the camera. Well, this is not a spoiler, because as you know, the title is MathMagic, a positroidal action on the deck of cards. So this is related with something more magical than only magic. This is related with math. So I will explain how it works, so how the mathematics works here. So I need a ver cómo puedo presentar. Okay, here. So now, can you see the slides?
Yes.
Okay, perfect. So again, my mathematical positroidal action on the deck of cards. So we need to talk about, first of all, positroids, because this is the object that allows us to have these magical properties in the cards. And with this, we are going to talk about the intuition test, the first trick that you saw, and then the second one, that is the color separation. So the first of all is what is a positroid, and what do we need to do? And what do we need to define it? So this is not necessarily necessary. The only thing that I want to focus more is like not the object, because we need a matrix. This is something more difficult to understand. The important thing is, okay, we have a matrix. What is a matrix? Try to imagine this like a generalization of linear independence. There is plenty ways to define it. And one of those definitions use something that is called a plethora bin. What does that mean? It doesn't matter. The idea is, okay, because we have like this generalization of linear independence, you can try to think in this like we are going to have vector spaces. And you know that vector spaces are linear algebra are related with matrices. So the idea is we are going to have matrices, and then we are going to transform the matrices in a vector. That's the idea. And how we are going to do it is like taking the determinants of something related with the matrix and then put it in a vector. And because we are using real matrices, the determinants can be zeros, positive, or negative. That's the idea. Okay. So when we have this way to transform the matrices into a vector, this is the idea of a matrix. Okay. So now, because of the determinants, as I told you, we have or zero or determinants equal 0, or determinants equal to a positive number, or determinants equal to a negative number. So we are going only to focus in determinants that is non-negative. So what does that mean? So we are going to have a positivity condition. So we are going to have this encoding that this is the matrix, and then we are going to put a positive condition. So we have a matrix with a positive condition. So we have a positroid. I know this is a creativity explosion for the name. But now the question is, why do we need to care about positroids? Well, this is because in 2006, in this paper, Total Positive Grassmanian Networks, Alexander Postnikov, who wrote that paper, showed that these positroids are in the bijection with a lot of combinatorial objects. Believe me, there are more than 15. But we only need to care about one that is called bicolored permutations. What is a bicolored permutation? It's a permutation. What is a permutation? Basically, when you want to rearrange numbers from 1 to n, this is a permutation. That's the idea. So now, when we have this rearrangement, we are going to put colors in the numbers. We can put a red color or a blue color. But we need to color the permutation with a special condition. What is the special condition? When we have an ascent, what does that mean? Is, for example, you have a number followed by a bigger one. This is an ascent. If you have that one, you must to color red and blue. That's the condition. So this is an example. This is an example of a bicolored permutation of size 12. The idea is, for example, if you see the 4 to the 8, okay. If someone here is a colorblind, this 2 here and this 1 here, this is no exponentiation, this is the color, just to differentiate between the red and the blue. But the idea is, okay, we have an ascent, we have the 4 and then the 8. So in that case, we must to color red and blue. Then we have the 7, the 6, 5, 3, 2. Sorry, 3 and 1. So in that case, we have this sense, so we can color as we want. In that case, I color red, blue, 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 and blue. But again, we have another ascent. We have 1 to 12. So again, we must to color red and blue. Then we have 11, 10, 9, and 2. Again, we have this sense, so we can color as we want. Now, the thing is that the coloring condition is the key for the trick. So, question for you. Can you guess why the color is the key? In the meantime, I will drink coffee because I need caffeine in my system. Try to think about it. Okay, spoiler, I will give you the answer. Why the color is the key? Well, it's because the actual cars is a bicolored permutation of size 10, because I use 10 cars from the intuition test. But the colors will be encoded in the orientation of the cars. You will see later what does that mean. So another thing that I use is something that is related with positroids, because remember that the bicolor permutation are related with positroids that are actually in bijection. So the idea is positroid are really symmetric. And as you remember, we have a condition for the ascent. There is actually, because the symmetry, sorry, you can also do an analogous definition for a descent condition. So the idea is we are going to have like two definitions for bicolor permutation, one using ascents and one using descents. That's the idea. But the important part is that the bijection, inverts the order of the permutation. You will see what does that mean in a moment. And the third thing that I use is we use small copies of smaller bicolor permutations inside the bigger bicolor permutation. Okay? So let's go to the camera again. Let me see. Dejar de presentar. And let me put the other camera. Okay. Perfect. So the idea is try to imagine that we have the domain. We are going to do a bijection, okay? So the domain of the function is like my hand, and the codomain is the table. What does that mean? So for example, if you start to see here, we have a bicolor permutation that goes 10, 9, 8, 7, 6, 5, 4, 3, 2, and ace. And ace is the one. So what happens if I start to dealing cards? Changing the orientation. Remember that the orientation is the color in the definition, no? So if I start to dealing cards from face down, from face up, if I do a switch here, sorry, I will do it here, I'm actually messing the order, because if you see we have ace, 3, 2, then it comes 4, 5, but if I switch these two, then comes 7 and 6. So I'm actually messing the order. But what happened if we didn't change the color? In this case, what happened if we didn't change the orientation? Well, let's see what happened. So if I start to dealing cards, for example, first let me do it like this. So if I start to dealing cards, we have the ace, we have the 2. But if I switch these two cards, then I have a problem here. Because remember that in the definition, there is not allowed to have like a descent and then an ascent, because we have to care about the color. So actually here we are messing the order. But if I only care about these two cards as a small bicolor permutation, the only thing that I'm doing is inverting the order from the smaller to the bigger, to the bigger to the smaller. But what happens if I take these two and put it together on the table? If you see, here, this is a valid bicolor permutation, because we have ace, 2, 3, 4. Then if I put this together, this is not valid, because this is 4, 6, and 5. So if I switch these two, this is messing the order in my hand, but on the table, it's staying in order. So we have 5 and 6. Then, for example, if I do another switch here, again, we are messing the order in my hand, but when you put this together in the table, this is valid. That's the trick. It's so simple, it's so silly that I love it. Well, actually, there are more, no? Because this is only happening if you don't change the orientation. So if you don't change the color. If you, as you saw at the beginning, if you start to dealing cards, changing the orientation, you are messing the order, no? But this is only happening if you are changing the colors of the bicolor permutation. This is how it works, the bijection. And the rest of the trick is, well, magician things. But well, this is the first trick. So let's go to the second one. So for the second one, let me go again. Like, let's change again the camera and let's present. Para-pa-pam. Share. Okay. So for the second one, for the color separation, I use again bicolor permutations, but in another way. So the idea is we are going to use something that is called group action. What does that mean? So basically, we are going to perform shuffles in a set, and the set is basically the cards. This is the idea. So now, for example, if you start to shuffle cards, the only thing that you need to use for describe this in a mathematical way is normal permutations. But if you want to do something like more extravagant, I will say, for example, changing the orientation of the card, as you saw before that I shuffle cards face up and face down, you need something else. So and in that case, we use bicolored permutations. The second thing that I use is, again, copies of a smaller bicolored permutations inside the bigger bicolored permutation, but with a little twist. Why? Because now every two consecutive cards are at the same time two bicolored permutations of size 2. One using the color and one the colors of the actual cards, so red and black, and the other, as before, using the orientation. You will see later what does that mean in action. So important, because remember that we have two different ways to define bicolored permutation, ascent and descent, so it depends of the parity of the cards. The important thing here is if we have two consecutive cards that have the same orientation, then they have different colors. You will see. And for example, if we have two cards that have different orientation, they have the same color. Those allow us to have, for example, this. If we know the color of a card and the orientation of the card, then we know the parity of the position. Or for example, if we know the orientation and the parity of the position, then we know the color of the card. Or another example, if we know the parity of the position and the color of the card, we also know the orientation. So the only thing that we need to do is preserve this property. And to do that, we need to use some shuffles that allow us to have this invariant in the cards. For that, we need to use something that is called Kato shuffles. What is a Kato shuffle? Easy. It's like it's named cut and turn over. So again, to cut the cards, we can cut at any point. So basically, that's separated into parts and then put one below the other ones. And remember that we have like a small permutation of size 2. So in that case, we need to turn over an even number of consecutive cards. So if we do these shuffles, we preserve the property. So let's go to the camera again to see what is happening here. Let me put here. Okay, perfect. So again, no, these are not. No están estas. So at the beginning, I had 5 cards. Ooh. I'm freeze? Oh, no, okay, perfect. So at the beginning, I have 5 cards. So I show you that I start to shuffle cards like face up and face down. This is a real shuffle. This is not doing nothing for the moment. So when I start to drink cards like deal, turn over, deal, turn over, deal, turn over, deal, turn over, deal, and turn over, now we have the property that I told you before. So for example, when I start to cutting the cards like this is cut, this is separated into and put one below the other one. Or for example, we can take an even number of cards and turn over together, for example, these 4. And this allows us to have control in this sense. For example, if you see these 2 cards, this is an odd position and this is an even position because this is the first one and this is the second one. But they have different orientations. And if they have different orientations, that means that this card here is a red one. So I can know that this is a red card. Or for example, these 2 here. Again, these 2, this is the first one, this is the second one. So this is an odd number position and this is an even one. So again, have different orientations. So this card here have the same color. If this one is black, sorry, this one is also black. Or for example, if we have these 2 cards together, this one have the same orientation. In this case, if they have the same orientation, they have different colors. So one is red and one is black. This is the information that we can preserve doing these permutations, doing this action of cutting and the Kato shuffles. So if you do that at the beginning, I told you to Geronimo, if you can deal, turn over, this is another different way to perform the Kato shuffles, a more magical way to hide the shuffles. But the idea at the end, when I say to Geronimo, this is the more important question, I start to link cards one by one. When I did this, actually, what I did was to separate the cards. This one were in the even position and this one in odd positions. So what does that mean? Again, because we know the information of the parity of the position and the colors and the orientation, at the end, we know that, for example, in this pile here, the face cards are red, the face down, sorry, will be black cards. So this one is black, and this one is also black. And vice versa. For example, here, the face up are blacks and the face down are reds. This one is red, and these two also are red. So the only thing that we need to do is turn over one of the piles. So in this case, we only need to do this or do this. And doing that, at the end, we end up having all the face-up cards with the same color. That's why at the end, I show you that all the face-up cards have the same color, in this case, the black ones, and all the face-down cards have the same color, in this case, the red ones. That's the trick. So actually, this is older because this is something related with something that is called the Homer principle. Let me go again to the presentation and stop here. So this is related with something that is called the Homer principle. Actually, because using the even number of cards in the magic world, the people always think that you only need to use, and you must to use always, an even number of cards. But as you see before, actually, we can use the bicolored permutation to try to encode the information of the shuffle, the cat shuffles, the information about the orientation of the cards, the color of the cards, and more than that. So that's why you can generalize this principle in something that I call the odd Homer principle. This is actually something related what I did in my PhD. But the important part is now you can perform, for example, the Homer principle using an odd number of cards. And if you want, this is an advertisement moment for me. Sorry. If you scan the QR code, you can go and check the preprint. And also, if you want to talk more about magic and math, you can also Google me. You can put Sergio Fernandez, or as I think that here I put my name like Sergio Matemago. You can also put Sergio Matemago. You can follow me on Instagram if you want, and YouTube. Yeah. So I hope that you really enjoy the tricks that I performed to you, the magic that you saw. So for your time and attention, gracias.